In this example, we will show the measurement of the fluorescence quantum yield of Rhodamine 6G in ethanol with an integrating sphere. The measurements are performed in the FluoTime 300 EasyTau. The first step is to insert the integrating sphere. Please insert the integrating sphere with caution in order to not hit any optical elements in the FluoTime 300. Now you can put the sample into the sample holder. Please use the provided sample holder stand while inserting the sample into the sample holder. Put the sample holder into the in position. Now you can put the sample holder with the sample in it into the integrating sphere. When the sample holder is in the integrating sphere, you can either choose the in or the out position. When the sample holder is in the in position, the excitation beam will directly hit the sample. When it is in the out position, the sample will only be illuminated indirectly by diffuse light originating from the sphere's surface. Now you can start the EasyTau software. Create a new workspace and give it a name. After that, you can start the quantum yield wizard. On the first page of the quantum yield wizard, you can enter the details of your sample and the measurement conditions. On the top, you can enter the sample name, you can choose a solvent, and you can write a comment for this measurement. Below that, you can choose a user, you can choose the excitation source, which is in our case the xenon lamp, and you can choose the excitation wavelengths and the detection range. In our example for Rhodamine 6G, we will choose 510 nanometers as excitation wavelengths, and we will choose the range between 500 and 700 nanometers as detection range. After that, you can click on the second step, which is Optimize Parameters, and start the optimization by clicking Start Optimization. Now the FluoTime 300 EasyTau software will find the best settings for your measurement automatically. After the optimization has successfully finished, click the Acquire Spectrum step and review the measurement conditions. If necessary, you can tweak the acquisition time. Click the Start button to run the measurement. Now the spectrometer will record the fluorescence spectrum of Rhodamine 6G in the chosen spectral range. It is necessary for the calculation of the quantum yield to record the scattering peak of the excitation light and the fluorescence spectrum of the sample. When the measurement is finished, click the Acquire Blank Step button. Before we continue the measurement, we need to replace the cuvette with the Rhodamine 6G in it by a cuvette with just the solvent in it, in our case ethanol. In order to do that, we need to remove the sample holder from the integrating sphere and put it back into the sample holder stand. Make sure that the sample is in the in position while you're doing that. Now you can easily remove the cuvette with the Rhodamine 6G in it and replace it by the cuvette with the ethanol in it. After that, you can put the sample holder back into the integrating sphere. Again, make sure that the sample is in the in position while doing that. Make sure that the sample and the blank sample will be measured at the same sample position, so either you choose the in or the out position for both measurements. Click the Start button to run the measurement. Now the spectrometer will record the spectrum of the blank sample in the chosen spectral range. After the acquisition of the blank sample spectrum has finished, click the Calculate QY button. On this page, a first estimate of the calculated quantum yield and calculated transmission is shown. Here you can also change the excitation range and the emission range, which is used for the calculation. To do a precise calculation of the quantum yield, you need to open the plot window. In order to do this, you first need to save and exit this measurement. In order to calculate the exact quantum yield out of the measured spectra, you first need to select the measurement for which you want to calculate the quantum yield. Here in our case there's only one measurement. And then click the plot tool. Now a new window opens. And it shows on the one hand the two measured spectra in blue and in red. And it shows the calculated absorption of the sample in green and the emission of the sample in black. On the right side of the window you can find the calculated absorption and calculated emission and the most important value, the quantum yield of the sample, which is in our case for Rhodamine 6G 92%. If you want to know how these values were calculated, you can click on the E=mc² button. Another window will open below the spectra. Here you can find all the equations which were used to calculate the quantum yield. Moreover, you will find the limits of the calculations and you have the possibility to readjust them.